Number 8. So Paige is conducting an experiment using 2 spinners. She spins each spinner, records the results, and then spins again. She repeats this experiment 10 times for each spinner. Her results are shown below. So based on the results, predict the number of times Paige will spin a blue from spinner 1 and spin an orange from spinner 2. If she repeats the experiment 300 times.
That would suck.
So let's do, so each spinner. So on spinner 1, we said it was out of 10. So the frequency was 10 times. That's our total for both. So on spinner 1, the probability that she spins a blue. Good, so 2 over 10. Or 1 over 5. And then on spinner number 2, spinning an orange. So 3 over 10. So we can find that probability first. So 1/5 times 3/10 to get our probability for both of those. So 3 over 50. Then we can set up our proportion. So 3 over 50 for both of those spinners, but if she does it 300 times.
100 divided by 50. So that would just be 900. 900? 900 divided by 50.
Good.
Thank you.
So 900 divided by 50.
Equals 18.
Good. $18 times. Number 9. Hannah draws a tile from a bag and records the results. The bag contains tiles labeled C, H, I, C, K, E, and N. Which of the following statements is true? So A says drawing a vowel and a consonant are equal likely. How many vowels do we have?
A-E-I-O-U.
So we've got 2 out of 1, 2, 3, 4, 5, 6, 7. And
this was chicken.
And a consonant, we've got 1, 2, 3, 4, 5. So 5 out of 7. So are they equally likely?
Oh, no.
No.
I have a new pencil.
B, she is 2.5 times less likely to draw a consonant than a vowel. 2.5 times less likely to draw a consonant than a vowel. So if we take the 5 times that it's going to take for the consonant divided by the vowels, so how many consonants there are divided by how many vowels there are. That would be 2.5. But it's 2.5 times more likely to draw a consonant than a vowel.
That's D.
Good. So then it's got to be D. She is 2.5 times more likely to draw a consonant than a vowel. Okay, number 10. Valerie's middle school has 700 students. She randomly selected a group of 80 students from her middle school and asked them their favorite hobby. She recorded their responses in the table below. Based on these results, which inference can be made about the number of students at her school who would name reading as their favorite hobby?
No.
So the first time she did this experiment, she randomly selected a group of 80 students. So that's how many we have here. So there's 80 kids that she talked to. She didn't talk to all 700 in her school. She just talked to 80 for this table. How many of those 80 picked reading?
12.
12. So 12 over 80, and we can make that a little bit smaller.
6 over 3 over 20.
Good.
Okay.
So 3 over 20, and we need to see out of her whole 700 students in her school, how many of those 700 would say reading was their favorite. So we can cross multiply and divide. 700 times 3 be 2,100 divided by 20. So when you set it up like that, 2,100 divided by 20, you can mark out those zeros, so that saves you a step when you divide it. So 2 can't go into 1, so we put a 0. Good. So Valerie concluded that 105 students at her middle school would prefer reading as a hobby. Number 11, an experiment, a fair 6-sided number cube, a dice, numbered 1 through 6, was rolled 2 times to determine the probability of rolling an odd number in the first roll and a number less than 5 in the second roll. The trial was repeated 10 times. The sample space and the data from the experiment are shown in the table below. So we did both of these rolls 10 times. So out of the first row, the question, what's the experimental probability of rolling an odd in the first roll and a number less than 5 in the second roll? So we're going to have to use this table. So out of 10, the first roll, they were looking for an odd number. So look in this first row, and how many odd numbers do we have? Good. 1, 2, 3, 4, 5, 6. Good. 3 over 5. And then the second row, they're looking for a number less than 5 in the second roll. Good, number less than 5, so 1, 2, 3, 4, 5, 6. Good. It's the same thing. So then we've got our 2 probabilities for the first roll and the second roll, and we're just going to multiply those 2 together. 3/5 times 3/5.
Wait, I'm confused. 36 over 100.
So once you reduce, you should have 9 over 25. Make sure you reduce because all of your answer choices will be reduced. So that'll help. You'll get confused if you don't reduce it all the way down.
Why can't you do it and then reduce it down?
You can get the answer and then reduce it, but a lot of people forget to do that. And then they think that there's not an answer choice. Okay, Gracie lives on a farm with 2 sheep, 4 goats, 6 chickens, and 12 cows. She's going to randomly select an animal to take to the stock show. What's the probability of randomly selecting a sheep or a chicken? Remember that word or means and pretty much. You're going to add those 2 together. So how many total animals does she have? Good, yeah.
24.
So 24 total animals, and then sheep and chicken together would be, right, 8 over 24. We can reduce that down. You can start with 2, or if you know 8. Good. 1 over 8 goes into 24 3 times. Good. But you can reduce that down one more time. 4 over 12 would reduce down to 1/3 also. Okay, number 13. Lily created a table of the possible outcomes of spinning a spinner divided into 4 equal sections labeled A, B, C, and D, and rolling a fair 6-sided number cube numbered 1 through 6. A sample space of the results is shown below. So the question is, using the sample space, what's the probability of spinning the letter D and rolling a number less than 2? So it's out of 24. That's how many we have in our total sample space. And then the letter D and rolling a number less than 2. So Lola said it earlier. There's only one of those. So how many of those shows a roll that landed on the letter D and a number less than 2? Just one, right? Mm-hmm. Do y'all see that? So 1 over 24. Number 14, Ben has a sock drawer that contains 3 green socks, 4 blue, and 2 yellow socks. Ben wants to know how often he can randomly select individual socks from the drawer and pull out a pair of socks that are supposed to say the same color. So it's supposed to say same. He randomly selects a sock with his left hand, and then he randomly selects a sock with his right hand without replacing. So that's important to know. If you need to read if he replaces it or not, because that could affect your outcome without replacing the sock in his left hand. Ben repeats the experiment 10 times, and the results are shown in the table below. So based on these results, predict the number of times Ben will randomly pull a pair of socks from the drawer that are the same color if he repeats this experiment 200 times.
I would not do that.
Okay, so out of the 10 times he did this, how many times did he pull the same colored socks out?
4. What?
So trial 2 it happened, trial 4 it happened, 6, and 9. So good, 4 out of 10. Can we reduce that down?
Yes. Mm-hmm. 2 over 5.
Good.
How do you do this so fast?
Okay, so 2/5, and then we want to see, so then out of 200 times, how many times are we going to pull the same color out? So we've got to cross multiply and divide again. So 400 divided by 5. Good. So 80 times.